Hi everyone, this is the gas walkthrough for May 29th. I'm Philip Newman, and I am solving An Egg in This Trying Time by Bill Murphy. The title is apparently a reference to Always Sunny in Philadelphia, which I have never seen, and probably I need to do something about that. But I did have to look up what the title was referring to. Bill uses a lot of songs for titles, but this is not one of them. But anyway, this is a killer and extra regions Sudoku. So we have normal Sudoku rules, 1 to 9 in each row, column, and 3x3 box, and in each gray region. So we need all of the digits 1 to 9 in these 9 cells, and in these 9 cells. Additionally, we have killer. The cages in the grid cannot have repeated digits, which is not an issue in this puzzle because they are all contained in a row or a column. But additionally, the digits must sum to the total given in the top left corner. Those are the rules. And we're going to start with these 3-cell cages. Often the place to start, especially in gas with killer, is your most extreme cages. So 6 for 3 cells is the minimum. It's the lowest you can have. You need 1, 2, 3 to make 6. And 24 is the highest you can have. 7, 8, 9. And it's especially important to start here in this puzzle because these cells are also part of this extra region. And so if 1, 2, 3 are here, they can't be in these cells. So where do they go in the box? They go up here. And same for 7, 8, 9 down here. All right, now we can look at these 2-cell cages to actually resolve all of these digits. And we can kind of do this in either order. So at the top, I'm going to look at the 5 first. 5 is 1, 4, or 2, 3. The highest this digit can be is 4. If we put a 5 here, we need a 0. So that obviously doesn't work. But we already have all of our low digits, 1, 2, 3 here. So this has to be 4. And it has to go with a 1. And then the 12 cage can't have a 2 in it because we would need a 10. So 3, 2, and 9 to go with the 3. Now, we'll do it in the other order this time. The 8 cage can't have an 8 or a 9. It must be 7, 1. And now because we have the 7, we know this is 6, 9. And this can't be 6. So that's 9, that's 6, and that's 8. Now the 5 cage down here can't be 1, 4, so it's 2, 3. The 15 can't be 6, 9, so it's 7, 8. And then we have 5 and 6 here. We have 4 and 5 here. All right. I have already solved this puzzle once this morning. My audio keeps, the settings keep changing slightly, or the noise in the room. I don't know what's going on exactly. I'm going to try and figure it out, though. But anyway, so I know the next place I looked was at these 5 and 15 cages. And initially, I just marked them 1, 2, 3, 4, 6, 7, 8, 9, because those are the possible digits. But then notice we have a 1, 2, 3, 4 quad here. And because we have a quad, we know these 4 digits must appear in these 4 cells. So 4 in particular has to appear in these 4 cells, and it can't appear in these 2 cells, so it has to appear here in the 5 cage, where it has to go 1. So that places a 1 here. The 6 has to go in the 15 cage in this box, because it can't go in those cells. So this is a 6, 9, this is 7, 8, and a 9 here. And now the 1, 4 looks down for 5, 4, the 6, 9 looks up for 5, 6. Okay, the next thing I did, I was looking at these pencil marks, and it made me realize something about this 10 cage. 10 in 3 cells, there are several ways to do it. You can do 1, 2, 7, you can do 1, 3, 6, you can do 1, 4, 5. The only way to do it without a 1 is 2, 3, 5. And we have a 2 or a 3 in this cell, so this can't be 2, 3, 5. It has to have a 1 in it. We have 2 1s looking at this cage, so this is our 1. Same is true with the 20. The only way to do 20 in 3 cells without a 9 is 5, 7, 8. But we have a 7, 8 here. So there is a 9 in the 20 cage. Okay. This 8 cage, we could have 5, 6, or 7 in it. But if we had 7, we would need a 1 to make 8. So this is 5 or 6 with a 2 or 3. Here we could have 3, 4, wrong digits entirely. 3, 4, 5 here. Can't have a 3 because we would need a 9. So this is 4, 5 with 7 or 8. Okay, what next? This 12, we can't have 4 or 5 in it. So the only possibility left is 3, 9. So we can just fill that in. And the 8 here can't have a 5 or 6 in it. So it must be 1, 7. We know the order from this one. The 7 looks over to give us 8 and 4. The 3 looks over to give us 2 and 6. And now let's look at these columns. We need 4, 5, and 8. 4 and 5 down here places 8. There's a 4 here to place 5. And then to finish the 20, 9 and 5 is 14, so we need a 6. I cannot type the right digits right now. 4 here gives us 1 and 4. The 6 here gives us 9 and 6. And then we'll look at this column next. We have 2, 4, and 5. So 4, 5 here. Not 4. 2, 6, and 5. 6, 5 here gives us a 2. And the 6 looks over to give us 5 and a 6. 1 plus 5 is 6, so we need 4 to finish that cage. Alright, these are 2 and 3 in some order. These are 7 and 8 in some order. And that's going to give us some pairs in the columns. I don't know that we need the pairs directly, but neither of these cells could be 2 or 3 anyway. But what are we left with? We're left with 5 and 7 here. 5 gives us 7, 5. These are 4 and 7 with a 7 looking over. These are 1 and 8 with that 1 looking over. These are 3, 5, and 6. We have a 5 looking up. We have a 3 looking over. This is 3. And then these are 2 and... I was going to say 6. 2 and 9. Alright, so now let's look in these rows to finish them off. We need 1, 2, and 4. We have a 1 and 4 here, so this is 2. We need 3, 5, and 6, and we have a 3, 6, so this is 5. Here we need 4, 5, 7. We have 4, 7 here, so this is 4, 7. And 6, 8, 9, we have a 6, 9 here. And this is a 6, 9 pair. Alright. And then kind of the last tricky thing to find. You can find this just by pencil marking everything. Actually, we can do it a different way. I'll tell you what I saw. The first time I saw 8. Can't go in these 2 cells. Can't go in this cell, so this must be 8. But what I just realized now is we have a 7, 8 pair and a 2, 3 pair in this row. So these are 1, 5, 9, and we can actually place them from these digits. So this is 5. And that 9 is going to resolve 6, 9, 6, 3. The 1 resolves 4, 1, and 7, 4. Last digit here is 2, which gives us 3, 2, 3, 2, 3, 2. Last digit here is 8, 7, 8, 7, 8, 7, 8. And to finish off, we need a 7 and a 3. And that is the solution. So really, we only use the extra regions for this opening, but it's a pretty important opening, getting the 1, 2, 3 up here, which can immediately be resolved. Same for the 7, 8, 9 down here. So really clever setup from Bill. Let us know how you found that in the comments, and I will see you next time.